In this video, we're going to take a look at one example where we will try to construct a confidence interval. So in this example, it says, given that sigma, standard deviation of the population, is 0.5, sample size is 25, and this is our hypothesis test. The null hypothesis says mu is equal to 3.0, and the alternative hypothesis says mu is not equal to 3.0. And x bar is our sample average, it's 3.18. So in part A says construct a two-sided 95% confidence interval on mu and interpret its meaning. Well, first of all, it says a two-sided confidence interval, and because our alternative hypothesis is indicating that the test is two-sided. It has this inequality sign. If it had less than or more than sign, then it would have been a one-sided test. So we're building a two-sided confidence interval. Also, it's a 95% confidence interval. Well, that means 1 minus alpha is equal to 0.95, which means alpha is 0.05. So let's try to construct that confidence interval here, part A. And we know that a two-sided confidence interval is here. This is the formula for two-sided confidence interval. So we're going to be using that, x bar minus z of alpha over 2. Z of alpha over 2, since alpha is 0.05, it's going to be z of 0.025 times sigma over square root of n. And upper limit is x bar plus z of 0.025 times sigma over square root of n. Now, if we replace these parameters with the numbers, mu is between, x bar is 3.18 minus, this z value, as we talked about before, and you can read it from the table, is 1.96 times sigma is 0.5, and square root of n is the square root of 25. And we're going to have the right-hand side, or the upper limit, and when you calculate and do the math here, you will see that the confidence interval, 95% confidence interval, is between 2.984 and 3.376. So how do we interpret this? What does that mean? Well, this example is, if you remember, is the continuation of the GPA example. Essentially, we are hypothesizing whether the average GPA of the university is 3.0 or is not equal to 3.0. Based on the sample that we collected, sample of 25, and this average that we took, the confidence interval is between 2.98 and 3.37. That means with 95% probability, the average GPA of the university is between these two values. That's the meaning of confidence interval. So let's write that down. With 95% probability, the true mean of GPA is between 2.984 and 3.376. So that's what this means. So essentially providing that interval or bracket on the population mean. For part B, it says construct a two-sided 99% confidence interval on mu and compare it with the 95%. So now 1 minus alpha is 99%, meaning that alpha is 0.01. So what is going to change from part A to part B? Still is a two-sided. The only thing that is going to change, this z value, is going to be z of 0.005. Right, z of alpha over 2 is going to be z of 0.005, and that is equal to 2.57. Now, if I change these values to 2.57, and this one also 2.57, and redo the calculations, I'm going to end up with mu between 2.92 and 3.43. Now, how do we interpret that? Very similar to the way we interpret the result in part A. Now, what we say is with 99% probability, same statement, with 99% probability, the average GPA is between 2.92 and 3.43. So what do you realize here by comparing these two confidence intervals? This confidence interval is wider. Both this value is more than this value, and this value is less than this value. So it's a wider confidence interval, it's a wider interval. And it makes sense because now you're saying with 99% probability the average GPA is between these two. Here you were saying with 95% probability is between. So if you're increasing the probability, you are going to have a wider confidence interval. And this is kind of on the face of it is counterintuitive, but when you think about it, it makes sense. As you increase the confidence level, the confidence interval is going to get wider. And we'll talk about that more. So let's look at another version of this example. Here we have a sigma, which is the standard deviation of the population. N is 30, x bar is 12.23. And we want to construct a 95% lower confidence interval. So in this case, looks like we probably had an alternative hypothesis of one-sided, which was probably mu more than, if you remember this example from before, mu more than 12.2. Now we only want to find the lower confidence limit. So if I go back a few slides back, here the lower confidence limit is here. So we're going to use that formula. L is equal to x bar minus z of alpha sigma square root of n. And here is 12.23 minus z of, because it's a 95%, alpha is 0.05. And here we have z of alpha times 0.08 over square root of 30. And this value, if you read it from the table, that is 1.64. And if I replace everything with numbers and do the math, I will get 12.2. So the 95% confidence interval is telling me that it starts at 12.2, and I don't have the upper confidence limit. I'm only calculating this for a one-sided test. Is this 95% confidence limit starts at 12.2.